Hello everyone. Today we are going to discuss K-map method. This is Dr. Michael from MLR Institute of Technology and we are discussing the subject Digital Electronics and Computer Organization. So first of all, this is a very important topic. It is useful to minimize the Boolean expression which ultimately results in fewer number of components to implement a digital logic Boolean expression. We are going to see introduction, how you can use K-map to solve the Boolean expressions. When we say solve, our focus is to minimize the Boolean expression. Then there are two categories of Boolean expression. We will see the two categories. One is sum of products and the other is product of sum. And here, as we have discussed, our focus is to minimize the expression. One could use Boolean algebra to minimize the expression, but we will actually see that the K-map method is easier. So, first let us see the steps to solve, and parallelly we will understand the steps with the help of an example that we have here. So, first step says, select the K-map according to the number of variables. So, according to the topic, one could give you a question like this and say minimize the Boolean expression using K-map. So, now according to the first step, select the K-map according to the number of variables. So, let us see how many variables we have. Okay, we have A, B, C. Again A, B, C, A, B, C, A, B, C. We don't have any D term, E term, F term, so on. So, we have only three variables A, B, C. Hence, we will have to select a K-map of this form. We are taking A here and then B, C here. A, B, C together, A, B, C together can have total 8 combinations starting from 0, 0, 0 to 1, 1, 1. 1, 1, 1 is 7. In digital form, 0, 0, 0 is 0. So, 0 to 7, total 8 combinations are possible. Hence, we are drawing 8 boxes. We are taking A here, we are taking BC here. Anyway, one could take. But which order is taken, the same thing has to be followed till the end of the final result. Okay, next, identify min terms. So, here min terms are in the form of, usually min terms are in the form of multiplication. How? Anything when multiplied, whichever is the least. For example, if in these three terms, first two terms are 1, but the third term is 0. 1 into 0 gives us 0. Means it gives us the minimum value. So, wherever you have products, those terms are called as min terms. So, identify min terms or max terms. That is what the second point says. Okay, in the question, we have min terms, that is identified. Next, let us see what form this is. This is plus stands for sum, and what is happening here? A is multiplied with B bar and then it is also multiplied with C. So, multiplication is nothing but product. So, we have sum of products. Okay, we have sum of products, which means it is SOP. So, here the point says for sum of product, write once in the boxes of K-map respective to the min terms. These are your min terms. First min term is A bar, B bar, C. This is the second min term, third min term, 4 min terms, means we will have 4 ones according to this point. If it is in SOP form, it is not in POS form, means we don't need to look at this point for this example. For some other examples, we could, if we are using this point, we don't need to look at the above point. So for this example, we don't need to look at this point because it is SOP form. Anyway, now let us see how to write ones in the blocks. Let us carefully look at the expression that we have here. The first term is A bar, B bar, C. So now in the K map, first we will write like this, 0, 1 corresponding to A because A could take values 0, 1. Now BC could take 4 values combination 0, 0, 0, 1, 1, 0, 1, 1. So we will write like this 0, 0, 0, 1, but we should not write 1, 0 because in 0, 1, 1, 0 nothing is common. K-map works by taking something in common. That is the reason after 0, 1 we are taking 1, 1 because the 1 here, this one and this one both can be taken common and we could get a simplified expression by using K-map. Okay, that's the reason we are taking this order. I hope the order is clear. Now what we are going to do is, we are going to write ones corresponding to this expression A bar, B bar, C. So here 0 is equivalent to A bar, 1 is equivalent to A. Likewise 0, 0, 0, it's like we are considering complement form. So B bar, C bar, because we have BC here, 0, 0 is as good as B bar, C bar. Likewise true form, first variable, okay, so first variable here is 0, 0 we have to take in complementary form and 1 we have to take it in true form. Again 1, 1, so both in true form. Again 1, 0, 1, 0 means B in true form, C in complementary form. Now what we need to do, we need to locate A bar, B bar, C. So let us see A bar, okay, this row, then next B bar, C means 1. That's the reason we are writing a 1 there corresponding to this. Now let us check corresponding to this A bar, B bar, C. So again, okay, again A bar, then A bar, here we have A bar, BC. So A bar, BC, okay, this one. Next, let us check this A, B bar, C. So A is here, okay, B bar, C is here, this one. Next, let us check this A, B, C. So A means we need to follow this row and BC, yeah, this one. So that is the reason we have a point here, okay. Put ones in blocks of the K map respective to the min terms. So here respective to the min terms, by looking at the min terms we are writing these 4 ones here. Okay, so after writing these 4 ones, we have earlier discussed that this works by taking what is in common, okay. That is the reason now we will see what is common in all of these 4 ones. Here rows are different, one is A bar, one is B, so we need to look at the columns. So if you look at these 2 columns, what is common? First expression, here we have B bar C, next BC. In B bar C, B, C, what is common? C is common. Hence the output is simply C. And here I hope the viewers have observed, we are trying to group all 4 together. The way we will do grouping is like this. Here maximum size is 8. If we have all ones, for example, if we have all ones, we could group 8 together. In this case, 8 grouping is not possible, so we will look if we can group 4 together. Yes, 4 grouping is possible here. That's the reason we have grouping like this. Okay, we'll give first preference for higher grouping. 8 not possible, we'll go for 4. If that is also not possible, we'll go for 2, and that's how we will try to simplify. Okay, and when we are grouping, we'll try to cover as many as possible, and that is what it means. You will give first preference for 8 if it is possible. If it is not possible, then only we'll go for 4. Then from the groups made in the previous step, find the product terms and sum them to get the sum of product term. So here, if you see, there is only one term. If we could have got some more extra terms, we could write plus and then those terms. Now let us discuss minimization of K-map when the question given is in POS form. So this is POS form. Why is it POS form? Because we have product of some terms. Product is multiplication. This term is multiplied by this term. And what the individual term consists of? It consists of some terms. If you see, there is addition. There is a plus symbol there. Hence, the given question is in POS form, product of some form. So, first, now how we are going to approach this problem? It is like this. Here, we have the first term consisting of A plus B plus C. So, what we need to do here? We will take, remember in POS form, the variable we will take in terms of 0. So, A, B, C, all we will take 0. Next, here again A 0, B 0, but there is a C bar. So, we have to take 1 because there is a complement term here. We are going to take 1. So, now we have two terms. One term is 0, 0, 0. Another term corresponding to 0, 0, 1. So, now what we need to do is we need to draw K-map. We are drawing K-map and we have 3 variables A, B, C. 3 variables can have total 8 combinations. If we have 3 variables A, B, C, we could have total 8 combinations from 0, 0, 0 to 1, 1, 1. Hence, we are drawing 8 boxes. 1, 2, 3, 4, 5, 6, 7, 8. We are drawing 8 boxes. Now, here, what we need to do is, we have 3 variables. Okay, A we are taking this side, remaining 2 variables we are taking on the other side. So, obviously, we get only 2 rows. B, C we are taking here, that's the reason we are getting 4 columns. And this sequence is same for any K-map which has 8 boxes. So, here 0, 0, 0. A is 0, B, C both are zeros, hence we are writing a 0 here. Next term is 0, 0, 1. So, 0, 0, 1. We are writing another 0 here. Rest all we can write once. Remaining all boxes we can write once or we can leave it as it is. Anything is accepted. Now, what we need to do is we need to pair this together. Here, what is common in these 2 zeros? They are in the same row. So, correspondingly, we have to take the A here. So, first term will be A. First term will be A. Corresponding to the 0, we are taking the true form. Next, in the column, what is common? In the column, if we see, okay, this first 0 is actually common. And that first 0 corresponds to the B term here. So that is the reason we will take B and then we'll write a plus, and this is the final result. What it means? According to the K map, this expression is minimized into this expression. So here if we see, this is a complicated expression. To solve that, more hardware is required, whereas this is a very simple expression, A plus B. Hence, less hardware is sufficient to implement this functionality. Now let us use Boolean algebra and see whether we are going to get the same result or not. So this is our final answer. We are using Boolean algebra to see whether this K-map method actually gives us correct answer or not. So now let us multiply this here. A plus B is same. Let us treat it as a single variable. Suppose Z. So Z into Z. Z into Z, if Z is 1, 1 into 1 gives us 1. If Z is 0, 0 into 0 gives us 0. Right? So we can observe that Z into Z gives us Z. So when we multiply these two terms, we simply get A plus B. Then when we multiply this term here, we get A plus B into C bar. Next, when we multiply this C here, we get C into A plus B. Last term, C into C bar. If C is 0, C bar is 1. 0 into 1 is 0. If C is 1, C bar is 0. Even then, C into C bar will give us 0 into 1, which is 0. So either case, always a value multiplied by its complement is always 0. When we are adding 0, we don't need to write. Now let us see this expression. Let us look at this expression here. AB is common, AB is common, AB is common. So let us take AB, A plus B. Okay, let us take A plus B common, and then if we take A plus B, we are left with 1 here. Here we are left with C bar, and then here we are left with C. The property of OR gate, dominance property, 1 plus anything gives 1. In Boolean algebra, 1 plus anything gives 1. So this entire term simply reduces to value 1, and 1 multiplied by A plus B gives us A plus B. So the final answer we are going to get is A plus B. So what we have done, we have used Boolean algebra. We got the same answer. Using K-map also we get the same answer, but K-map is easier and it is visual based. Hence, psychologically from student point of view, it appears very simple. So today's lecture we have seen K-map, steps to solve the expression using K-map. We have seen both SOP and POS form, and that's all for today's class. Thank you.